Welcome to adding and subtracting polynomials. So in this lesson, we're going to take any kind of polynomial, let's say a binomial, and add it with, for example, a trinomial. For my first example, I have 11x to the third power minus 8x to the second power plus 12 plus the whole polynomial of 17x to the fourth power plus 8 to the x to the second power minus 9x to the seventh power plus 4 minus 2x to the third power. So in this case, we are adding two polynomials. You can see it from right here. I just want to tell you that if the two polynomials are surrounded by parentheses, that actually means something very important. So the first polynomial here on the left-hand side is technically led by the number 1. Sorry about that. Let's see if I could do better. So when you distribute a 1, don't forget multiplying anything by 1 results in the same thing that you already have. You'll see in the next step. That means that I'm actually going to have this exact thing without any parentheses. This plus sign is not just a plus sign, it is secretly a positive 1. A positive 1 is what you would distribute with all of these. And you can see that none of the values are going to change because it's a positive 1. You'll get the same thing, the same factor that you multiplied with the positive 1 in the first place. So let's see how this happens. Oops, sorry. And don't forget that it might not matter for adding polynomials, but for subtracting, recognizing the 1 is going to help you. So just as I said, I rewrote everything without the parentheses, and I highlighted the terms that I can combine. For example, 11x to the third power can combine with negative 2x to the third power. Negative 8x squared can combine with 8x squared. And 12 can combine with 4. And this is what you would get. 11x to the third power minus 2x to the third power is 9x to the third power. So notice I underlined it in yellow so you can see where it came from. 12 plus 4 is 16, and that's where that one came from. Notice I don't have any orange, and that's because negative 8x squared and positive 8x squared are going to cancel each other out. So that's why it doesn't exist in my next step. Right? And then after that, you just got to put it in the correct order. So that would be the correct order, and I will describe to you what I mean. So we want to do descending order based on degree. So 7 was the highest degree, 4 was the next highest degree, 3, and then the constant number, 16. Don't forget that 16 technically does have an x. It's 16 times x to the 0 power. Anything to the 0 power is 1. 1 times 16 is just 16. And that is how you add two polynomials. All right, so now let's check another example. So here I am just adding the two polynomials. Don't forget, like I told you before, this is a positive 1. This is a positive 1. When you distribute on both sides, you can see that nothing's going to change because it's a positive 1. So I rewrote it without any parentheses, and I highlighted those terms that I can combine. Negative 6x and negative x. I can also combine positive 3x to the 10th power and positive 4x to the 10th power. So when I did the blue highlighted, negative 6x minus x, you get negative 7x. Positive 3x to the 10th power plus 4x to the 10th power is 7x to the 10th power. X to the 5th power did not have a partner, so I just brought it down. And the 17 I also brought down. Okay. Then from here, you have to put it in descending order by degree. And don't forget, by degree means whatever exponent is attached to the x. So we go from 10 to 5 to an invisible 1 to a 0. So the correct answer is the one on the bottom. Don't forget when you do rearrange this that you always keep the sign on the left. So for example, this negative 7x, you have to keep that sign when you rearrange it because we're not moving it across the equal sign, we are just rearranging it. And then, for example, this 7x x to the 10th power has to stay positive. So it's whatever sign to the left of the term you're rearranging. Okay, so now for this example, I have subtraction. I'm going to subtract both of these polynomials. Before I start, remember there's an invisible 1. So in this case, this polynomial is going to stay the same with no parentheses. Okay, now let's talk about the other side. Notice there is a minus, and that is not just a minus sign, that's actually a -1 that needs to be distributed. So then that means that this polynomial here is not going to be the same. It's actually going to be changing signs. So that is why subtraction is not commutative. So you have to be very careful when you translate a word problem, for example, to get to this point, and then make sure you distribute that -1 before you do anything like combine like terms. So that is what I'm showing here with my arrows. I'm going to distribute that -1. And so just like I said, the first polynomial remained the same, but the second one changed. So instead of a -9x to the 4th power, it became positive. Instead of a positive 3x squared, it became a -3x squared. And instead of a -10, it became a positive 10. Now you're ready to highlight whatever you can combine. So I'm going to be able to combine -9x to the 4th power and positive 9x to the 4th power, which happens to cancel actually because they're the same value, opposite signs, and +1 and 10. So then if I combine the 1 and the 10, you get 11. I left the 18x to the 6th power by itself and the -3x squared by itself because it didn't have a partner. And then you rearrange it based on degree. So remember, that means you have to start with your highest degree, which is 6, and then we have a 2, and then we have a 0. Don't forget, when you move things around, just make sure you keep them the same sign they were. This was a +18, this was a +11, and this was a -3x to this 3x squared. Okay, here's another one. So remember, your first step is to distribute the -1. So this is not as easy as addition. Addition, things kind of stay the same, but here you can see that this whole polynomial changes its identity. So instead of -3x squared, it becomes positive. Instead of +4x to the 3rd power, it becomes negative. And instead of -5, it is now positive. Then you're ready to identify which terms you can combine. So in yellow, we have anything that is x squared, so degree of 2. So we can combine -13x squared with +2x squared and +3x squared. And the orange represents degree 3, so -8x cubed and -4x cubed. So if you combine all the terms, -13 plus 2 plus 3 is -8x squared. -8x to the 3rd power minus 4x to the 3rd power is -12. Then just make sure it's in the correct order. So 4, 2, 3 is already messed up, so we have to rearrange it. So when you rearrange it, you have 7x to the 4th power minus 12x to the 3rd power minus 8x squared plus 5. That would be the correct order. So here I have a combination, and I'm going to show you what to do. First step, let's get rid of this negative, and we're going to distribute a -1. Sorry about that. Let's see if I can do better. To the 2x and -7. Don't forget that the first parenthesis does technically have a +1. So this can be rewritten without the parenthesis because 1 times anything doesn't change it. And on this side, this is technically also a +1. And when you distribute, nothing's going to change. So they can get out of their parentheses as well. So that is what I wrote. Notice that everything stayed the same here. Everything stayed the same here. The only thing that changed was the +2x became negative and the -7 became positive. In case anybody was confused, this does seem like something changed, but 1 times -3 is -3. Nobody writes plus minus, so I just circled it and put a minus sign, in case anybody was wondering about that. Then I'm highlighting 6x to combine with negative 2x. Negative 4x squared can combine with negative 5x squared. Positive 9 can combine with 7 and negative 3. And when you combine all the terms, I did 4x represents what I got when I did 6x minus 2x. Then 9x squared is what I got, negative 9x squared is what happens when I got negative 4x squared minus 5x squared. And then finally, the positive 13 resulted from 9 plus 7 minus 3. And now just write it in the correct order. Make sure you keep the sign to the left. So if this is a negative 9x squared, then this needs to stay as negative. This is positive. This is positive. Remember, this is just rearranging. I'm not moving things across any kind of equal sign. If there's any questions, please let me know on Google Classroom or through email. And this template was from SlidesGo.